Right, so it's a simple factual one. So the image formed by a converging lens, right, gets larger as an object gets closer to the lens. Oh, basic common sense, faraway objects are small because their image is small. Right? Nearby objects are large because their image is large. Yep.
So as faraway object is faraway one word?
Yeah.
See, all these learning outcomes, are they just in the book?
Basically in the book it states this is what you need to know, but the answers to them are what are in your notes. Okay, there is also a typed, if you'd rather just go from a typed version, there's a typed version on Schoology. No, not in class, but it's just for your revision if you're trying to check your notes are complete.
So do we need to write these down?
Yeah. Okay. So accommodation of the eye is its ability to change the shape of lens as objects get closer or further away. Nearby objects, right, we just found in the experiment, require a thicker or more powerful lens. And faraway objects need a thinner lens, right, less powerful. Now, as you move objects further and further away, then the angle the rays come in gets smaller and smaller. And so the rays from a distant object, effectively the angle is zero. Or what we say is that the rays are parallel. All right, so when we're looking at images of the building across the road, the rays coming in from them would be effectively parallel.
Sorry, does that say objects get closer or
Yep.
further away?
Yeah, get closer or further away.
What is parallel?
Or it should be, yeah, you're right, it says of instead of or. I'll show you in a diagram in the next one what we mean by parallel as well, if that helps, if you're not so sure. But it just means all going in the same direction. Sorry, that word back there is or. So for a distant object,
See, if we didn't finish that, we just move our station.
Yeah, yeah, and get it from YouTube. So you've got an eye with a lens at the front, and it's a thin lens for a distant object. Then the rays come in parallel. What we mean by that, remember, is all of them are pointing the same direction to start with. And what the lens does, and what it's always trying to do no matter where the object is to bring them to a focus on the retina. So all three rays should meet on the retina. For a nearby object, that's a bit harder, because the rays from a nearby object are still spreading out. So we get a similar sort of diagram, but we need a thick lens at the front of the eye to deal with that. So the rays from a nearby object, the middle ray always goes right through. That's nice and easy to deal with.
Is that not one of the questions?
It may well be, yeah. Is it not in the second TMA?
Yeah.
Yeah, it doesn't have to be completed for today. Right, I should have put these wee arrows on the first diagram as well. So for a far away, for a nearby object, sorry, you need a thick lens to bring the rays to a focus.